So today we're going to be looking at your quadratic function. With these quadratic functions, you are working with a polynomial function. Your degree, however, is 2. So the power on your first term is 2. So these quadratic functions will look like a U when you're working with them. Okay, so again, that's anything where it's f of x, g of x, h of x, anything is equal to something times x squared. So x is going to be raised to the power of 2. If you look at any of these functions, they're going to look like a... again, these make a parabola, which is a U-shaped graph. Okay, within that U-shaped graph or line, you have something called an axis of symmetry. That axis of symmetry cuts the parabola in half. That always is going to be x is equal to something. So wherever the parabola is cut in half to where the two sides are mirrored, is x is equal to a number, and that is your axis of symmetry. So with that parabola, which is a U, within that parabola you have something called the axis of symmetry, which is just an invisible line that cuts that parabola or that U in half, so that way both sides mirror each other. That is also considered as your axis of the parabola. We don't call it that. We call it the axis of symmetry, though. The point that axis of symmetry goes through is called your vertex. It's literally the highest or lowest point that you have where that curve happens within that parabola. In mind, again, keep in mind. So within these parabolas, that what we're going to look at is domain and range. So domain are what are the x values that are being covered. Your range are what are the y values that are being covered. You're going to be giving that in interval notation. So try to remember about your interval notation. These are going to be, you're also going to be looking at increases, decreases, and constants. You are going to be using your x values for these. And you're going to be reading this from left to right, just like you do a sentence. So from left to right, if you look at this graph that we see here, from A to B, from the point A to the point B, you are increasing because it goes up from left to right. It would increase between the values of A and B because those are the x values that it increases at. Then from B to C, from left to right, it goes down, so it's decreasing between those two values. Then it goes up again from C to D, so it would be increasing from C to D. And then that line goes constant. That line goes constant, and it would be from the D to E. So again, that's constant because it's just a horizontal line, straight horizontal line from left to right. Completely, like they look like these, but they're going to be cut in half. That is your axis of symmetry. So like with this one here, that dotted red line is your axis of symmetry because it cuts the parabola in half, and you can literally fold it and it mirrors both sides. Within these graphs that you see here on your next page and these examples, you are going to be identifying the domain, the range, the increase, the decrease, your maximum or minimum, your zeros, so anywhere the parabola goes through your x-axis, and then the axis of symmetry. So with the first part, our domain and our range. For any of these x squared values or x squared functions, your quadratic functions, automatically your domain is all real numbers, which means it would go from negative infinity to positive infinity. We're looking at just this graph here on the top left. So with this, for the range, you're going lowest value to highest value. So your lowest value here where that curve is happening is at 0. It includes the 0, so we're going from 0 up to infinity. The 0 gets the bracket on it because it includes it. From here, we're going to look at increase and decrease. From left to right, you are increasing from 0 all the way to the right. It never ends. It keeps going up and to the right. So that means that you are increasing from 0 to infinity. Again, we're looking at x values for increases and decreases. For your decrease, you're going down from left to right from the x value of negative infinity to the x value of 0. So that would just be from negative infinity to 0. Your maximum or minimum value comes from your vertex. Your vertex is the point that you see here that is at 0, 0. This point here at 0, 0 is your vertex. Whatever the y value is from that vertex is what you get your maximum or your minimum from. That vertex point is a minimum point here, so I'm going to circle minimum, and then I'm going to put what y is equal to from that vertex. So in this case, y is just 0. Your zeros are where that parabola or that line cross your x-axis, is what x is equal to. In this case, it only touches your x-axis once at 0, 0, so your zeros are just x is equal to 0. Your axis of symmetry is that invisible line that cuts the parabola in half vertically. So that would be here, right down the middle at x is equal to 0. It's also whatever the x value is from your vertex. For your second example here, you have a parabola that opens down. So your domain, again, originally we said that it's always going to be all real numbers, so that's going to be negative infinity to positive infinity automatically. Your range, however, since this parabola opens down, it's going to negative infinity. So we're going from negative infinity y value-wise up to 0, and then it includes that 0, so we put a bracket on the 0. You are increasing from left to right on the left side here. So that goes from negative infinity up to 0. You are decreasing from left to right on the right side of this parabola. So that goes from 0, including the 0, to positive infinity. Again, we're looking at x values when we're doing increases and decreases. For this one, you have a maximum value, so I'm going to circle that because the vertex is your highest point. And that is at y is equal to 0. Your zeros, again, is just x is equal to 0. And then your axis of symmetry cuts that parabola in half vertically. So that would be x is equal to 0. Because, again, it's the x value from your vertex. Your vertex here is 0, 0. With this, the next example that we see here, a little different placement here. Your domain for this function that's on the left is automatically what? Negative infinity, positive infinity, so all real numbers. Your range, what is your vertex point? Your lowest point that you see here is the point negative 5, negative 2. Okay. Or sorry, positive 2. Thank you. From here, take your range. What's your lowest value, lowest y value from this graph?
Negative 5.
The lowest y value. Y. Up and down. 2. It includes that 2, so we're going to put a bracket on it. Where is this graph going? Where is this line going? Infinity. So your range is from 2 to infinity, including the 2. Increase and decrease. Look at your x values for these. From left to right, where are you going up?
Negative 5 to infinity.
Negative 5 to positive infinity. So it includes the negative 5, and it goes up to positive infinity. From left to right, look at your x values. Where are you going down?
Negative infinity to negative 5.
Negative infinity to negative 5. Good. From here, that vertex is our highest or our lowest point? Lowest. So we have a minimum value. What's the y value from your vertex? 2. So y is equal to 2. That is your minimum value. For next, you have zeros. Does this line cross over your x-axis anywhere?
Yeah.
No, it doesn't.
Oh.
The black line, that's your parabola. Does it cross over the x-axis anywhere? No. So there are none for your zeros. For your axis of symmetry, the dotted line that we see here that cuts that parabola in half has an x value of what? -5. It's the x value from your vertex. That's it. For your last example on this page, you have a parabola that opens down. Your vertex is at what point? -3, 5. From here, we're going to find the domain, the range, increase, decrease, maximum, or minimum, and its value, the zeros if we have any, and the axis of symmetry. Your domain automatically, since we have a parabola, is from -infinity to +infinity. Your range, parabola opens down, so it's going to -infinity. We're going to put that down first, up to the y value of 5. Oops. And that 5 gets the bracket. Your next one, or your next part, goes over increase and decrease. From left to right, your increase is from where? It's going from -infinity up to the -3. Your decrease happens from that -3 to +infinity. Again, we're looking at x values here. So that goes from -3 to +infinity. Our vertex is our highest or our lowest point. It's our highest, so we have a maximum at y is equal to 5. Next, we have zeros where? Our line goes through our x-axis here and here. So we're going to call this -4, 5, 6, and 0. So we would just put -6 and 0. Your axis of symmetry has the x value from your vertex, so x is equal to -3. Skip over this part, but graph these today so you get the concept of the way that they look, and then later on we'll go back to pulling out that information from those graphs. So with our first one that we have the graph of g of x is equal to the opposite of x squared plus 1. I'm going to give you the function table with your x values. You're plugging in those x values, simplifying, plotting the points on the coordinate plane, drawing your line through it. So with this function table, we have x values of -3, -2, -1, 0, 1, 2, and 3. We're going to start with the -3. We're going to have the opposite of -3 squared plus 1. The opposite of -3, the -3 squared is what you do first, so that's 9. The opposite of 9 is -9. -9 plus 1 is -8. Then moving down to the -2, you have the opposite of -2 squared plus 1. So the -2 squared is 4. The opposite of 4 is -4 plus 1 is -3. Then we have -1, so it's going to give us the opposite of -1 squared plus 1. -1 squared is 1. The opposite of that is -1. -1 plus 1 gives us 0. Next we have 0, so that's the opposite of 0 squared plus 1. 0 squared is 0. The opposite of that is still just 0. Plus 1 is 1. Next we have the 1. So this means that we have the opposite of 1 squared plus 1. 1 squared is 1. Opposite is -1. Plus 1 is 0. Next we have the 2. So the opposite of 2 squared plus 1 gives us 4, which is -4 with the opposite of it. And then plus 1 gives us -3. Then that 3 gives us the opposite of 3 squared plus 1. So 3 squared is 9. The opposite of that is -9. Plus 1 is -8. If we look at our g of x or our y values, these all give us, literally, you have 1, 0, -3, -8. On the bottom of that 1, you have 0, -3, -8. So you're going to be mirroring on both sides of that 1 value for y. So with these, it gives you the ordered pairs of -3, -8, -2, -3, negative 1, 0, 0, 1, 1, 0, and 2, negative 3, as well as 3, negative 8. So if we were to go to graph these ordered pairs on our coordinate plane, your negative 3, negative 8, you're going to go to the left 3, then down 8. Plot your point there. Then the negative 2, 3, left 2, down 3. Plot your point there. Negative 1, 0 on your x-axis at negative 1. Then 0, 1 on your y-axis at 1. 1, 0 on your x-axis of positive 1. Then 2, 3 to the right, 2 down 3. You're mirroring the point on the other side of that y-axis. Then you have 3, negative 8, so to the right 3 and down 8. From here, you just draw your line through those points. So we see here that this line curves and forms like an upside down U. That upside down or opening downwards is because of that negative that's in front of that x squared. If we look at our last example, we're given h of x is equal to x plus 2 squared minus 3. We're also given x values of negative 5, negative 3, negative 2, 0, 2, and 4. So if we start with that negative 5, this is going to give us negative 5 plus 2 squared minus 3. The negative 5 plus 2 is negative 3. Negative 3 squared is 9. 9 minus 3 gives us 6. Next, for the negative 3, we have negative 3 plus 2 squared minus 3. The negative 3 plus 2 is negative 1. Negative 1 squared is 1. 1 minus 3 is negative 2. For the negative 2, that's going to give us negative 2 plus 2 squared minus 3. Inside the parentheses, you have 0. 0 squared is 0. Minus 3 is negative 3. Next is 0. So that's 0 plus 2 squared minus 3. 0 plus 2 is 4. 0 plus 2 is 2. 2 squared is 4. 4 minus 3 gives us 1. Next we have 2. So that's 2 plus 2 squared minus 3. The 2 plus 2 gives us 4. 4 squared is 16. 16 minus 3 is 13. Then with that 4, we have 4 plus 2 squared minus 3. So 4 plus 2 is 6. 6 squared is 36. 36 minus 3 is 33. So these all give us the ordered pairs of negative 5, 6, negative 3, negative 2, negative 2, negative 3, 0, 1, 2, 13, and 4, 33. Now, if you see here, these y values, some of them are much larger than the y values that your graph gives you. So you're not going to be able to plot those ordered pairs, which is totally fine. You do still have some that you can plot, which you will. So for the first one we have is negative 5, 6. So we're going to go to the left 5, then up 6. Plot your point there. Next we have negative 3, negative 2. So to the left 3, down 2. Plot our point there. Then negative 2, negative 3. So left 2, down 3. Then we have 0, 1. So right or left, none, but up 1. And then we have 2, 13, which is going to be about up here. So you'll see here that we have a curve that's happening, and then we have this random point. So this random point that's on your y-axis, let's look at that and reevaluate this a little bit. So that 0, 1, you have 0 plus 2, which is 2. 2 squared is 4. 4 minus 3 is definitely 1. So we're going to look here and see we're missing the number between negative 2 and 0. So if we plug that in, that would give us a negative 1. So that would be negative 1 plus 2 squared minus 3. The negative 1 plus 2 is 1. 1 squared is 1. Minus 3 gives us negative 2. So that's the ordered pair negative 1, negative 2. So we could also use that ordered pair. Okay. So from here, we would see that we have our curve happening here, and our line would just continue to go up on that right side. So again, you might not necessarily use all of the order pairs that you're finding. Like you could also have plugged in 3 and 1 to get more precise order pairs to make that line look a little bit better for you when you go to draw the line through those points.